Hello guys, this is Ankit from nactuscenter and this is the very first video from nactuscenter. Today we will discuss about the lasers and the concept behind the laser. So I'm starting the article, that is laser. It is known to be a very interesting article in today's youth, that what does laser stand for, what is the phenomenon behind the laser and how does it work. So starting with the abbreviation of a laser, it just simply stands with light, amplification, by stimulated emission of radiation. So you can see that each letter of a laser has been acronymed to like L, A, S, E and R. In addition to this, maser concept was also introduced. Maser was basically proposed for some contradiction results of a laser. We will study it later on. In maser, first of all I will tell about the acronym of the maser is microwave, amplification, again by stimulated emission of radiation. Okay. So today we will over to the concept of only lasers, and by describing that we will over to the concept of maser, then why maser has been introduced, why not laser is found to be so sufficient. So starting with the laser concept, I would like to tell you that laser was introduced in 1960s. First of all, before that, Einstein in 1916 proposed that interaction of a radiation with matter could be explained in terms of three basic properties. That basic properties are, first one is stimulated absorption, second is spontaneous emission, and third is stimulated emission. Now I would like to highlight one point, that why I had left some space between stimulated absorption and spontaneous emission, stimulated emission. The very easy concept to remember that these two, this is the one which only includes absorption process, remember, and these two are includes in one which includes only emission process. As you can go through this and see, this is spontaneous emission, this is stimulated emission, and this is stimulative absorption. So we will discuss it in detail. First of all, I am starting with the stimulated absorption to discuss about. Starting with the article, stimulated absorption. Remember, I am taking absorption process, not emission process. So there is a far difference between these two cases. Now suppose that there is a radiation of a frequency mu. Suppose a frequency mu are incident on a matter having atoms with a ground energy level. If I would like to draw it for your better understanding, it will be like this. There are two energy levels named as E1 and E2. Remember that E1 is the low energy level and E2 be the upper energy level. Now, suppose there is some atoms lying in the ground energy level A1, and when suitable radiations are fault on that atom, like the atom with this, when suitable radiations is allowed to fall on that atom, then atom lying at this ground energy level will excite to the upper level, that is at E2. So I am repeating again, when suitable energy, let the energy be h mu, it is not let, it is must. When suitable energy of h mu, h being Planck's constant, mu being the frequency, is allowed to fall on the ground state E1, then atom lying at the ground state will allow to excite at the upper stage at E2. Now, as I had allowed to fall h mu type of energy, then h mu must be equal to E2 minus E1. Then the radiation photon is absorbed and electron jump from the E1 to E2. When radiation photon of h mu is absorbed by the atom lying at the ground state, then atom will jump from E1 to E2. So this is the, if I would like to draw it again, then suppose E1 with the ground energy level, E2 with the upper energy level, when there is no energy, no suitable frequency of energy is allowed to fall on the E1 lying atom, then the electron will lie here only, that is before collision. But after collision, when the photon of suitable energy, that is of h mu, is allowed to strike on the atom lying in the E1, that is ground state, then atom or electron lying in the ground state will excite it to the upper state at E2. This is after collision, this is before collision. So this is called stimulated absorption or simply absorption. It requires only, what does it require? Only incidence of photons of a definite frequency or energy. Remember, frequency must be suitable to incident on ground state electron, so that electron must jump to upper state, that is excited state. So this was the concept of stimulated absorption. Remember to make notes.